Welcome to East Academia. My name is Brian Wadena, and my colleague's name is Emmanuel Ambua. So today in this video, we're going to talk about capacitor and second balance, or which is known as capacitor charge balance rule, which other people just call it capacitor charge rule. Other people just call it the charge rule. So the statement, is defined as the average value of the inductor current is 0 in steady state or equilibrium. So the mathematical expression is given as follows. Now, we can derive this expression or this charge rule using in the following way. So we have the current through the capacitor IC is usually given as C dVc. The voltage dVc is nothing but the voltage of the capacitor dt. In this case, we can rearrange this expression such that it looks as 1 over C is equals to dVc over dt. Similarly, we can have dt on this other side such that we'll have 1 over C over C dt is equals to dVc. Now, we can integrate both sides of the expression over a complete period, and you're going to have Vc, this will give us nothing but Vc, is equals to 0, an integral from 0 to t, 1 over C, Ic, dt. Again, coming to Vc, Vc is nothing but the difference because we are considering a starting point and a final point. Okay? So in this case, Vc will be nothing but Vc, that's the final value at the period, minus the initial value, okay, over 1 over C is equals to 1 over C, 0 to t, Ic dt. Now, as in the previous video of the volt second balance rule, with the assumptions that we are making here. The first assumption we said is that you are going to assume that the steady state conditions have been reached. So steady state conditions have been reached. Steady state conditions reached. The second assumption is that the voltage across the capacitor, so voltage across this capacitor, rises and falls linearly. Okay? So having assumed these assumptions, we can draw this as follows. Okay, so this is at time when it's 0. Okay, so this is during the charging period, that is when the on period, and this is during the discharge period. Okay, so you can say this is off, the off period. Now, so from this diagram, we see that this final value here, this t is equals to the period, is equal to the initial value. Okay? So in that case, the difference between the final value, that is Vt minus Vc, is going to be 0 since they have the same magnitude. Okay? So this statement here can be simplified to 0 is equals to 1 over C, integral of 0 to t, Ic dt. Okay, so we can multiply by C each side. Still, you're going to get 1 over 0 is equals to 0 to t Ic dt, like that. And we can divide by t on both sides of the equation. This will be nothing but 0, equals to 1 over t, integral from 0 to t Ic dt. Okay? Okay, sorry about that. We just want to write a clear version of it. So this is going to be nothing but 1 over t, integral 0 to t, Ic dt is equals to 0. And as you can see, this is nothing but where we started. So we've derived the capacitor charge balance rule. So this diagrammatically, we can draw it as follows. And you have this is IC, and you have time t. Okay, so the area under the curve here is nothing but we'll have the units of current, amperes, and this one is given in seconds, this one is given in amperes and seconds, and this is just nothing but coulombs, okay, which is a unit of charge. Okay, so we know we have this, I think I drew it. So current times time gives us nothing but charge. So because of this, it's known as the amp, is known as the ampere second balance, or ampere second balance, you can simply say charge balance rule. Okay, so thank you for watching. Please don't forget to subscribe and to click on the like button and share, and to click on the bell icon for notifications when you upload a new video. Thank you.